Let us now go to the second one. The second one now we are referring to what? We are referring to a turning points. We are referring to the turning points, right? How do we determine the turning points of the cubic functions? No, we are not going to use x is equals to minus b over 2a. Remember here we said we must do what? We must find f prime of x. We must find the derivative of the function f, right? Now, we have f at x is equals to what? Is equals to x with the exponent of 3 there, minus 4x squared, and then plus 4x, right? And then from here, we must find the f prime of x. Do you still remember how to find the derivative? Do you still remember? Yes, you remember. If you have what? F of x there, no, f of x is equals to ax to the power of n. Now, f prime of x will then be what? F prime of x will then be, you take n, multiply by a, you have a times n, and then x, and then from that n, you just subtract 1 there. You would have something like that one. It's very important to know how to find the derivative. You know how to find the gradient, because we refer the derivative also as a what? As a gradient, especially when we deal with this one, so that at least you can understand what is it that you're talking about. Okay, right. What will be the derivative of x to the exponent of 3? Of course, we look at the coefficient. What is the coefficient there? It's 1, right? And now we say 3 times 1, that is 3. And then, of course, from the exponent to minus 1, then you're going to have 2. That is 3x squared. And now from here, what's going to happen there? 2 times minus 4, it's a minus 8, of course. And now 2 minus 1 is only a 1. And therefore, here we have what? We have a plus 4. Therefore, the derivative of f of x there is f prime of x is equals to 3x squared minus 8x plus 4. Right. Now, are you happy so far? Good. Now, what do you know about the derivative at the turning points? What do you know about the gradient at the turning points? Of course, it's very important to remember that at the turning point there, the derivative f prime of x there is equals to 0. The gradient at the turning point is equals to 0. Good. Now, then it means now we must equate the derivative to what? To 0. Then we'll have 0 is equals to 3x squared minus 8x plus 4. We'll have 3x squared minus 8x plus 4. Good. Now, what type of the equation is this one now? That is a quadratic equation name. That is a quadratic equation. Do you know how to solve the quadratic equation? Yes, of course. First of all, we look at the common factor. You look at the factors. If no factors, then we can use the quadratic formula. Right. Now, let us see now if we can have factors for this one. Let us see. Do you have the factors? Or you're still looking at the factors? Okay. Right. Now, let us see now. It means now we start first with the first term, and now we go to the last term there. Now, the first term is 3x squared. What are the factors of 3x squared? That will be 3x multiplied by x, right? 3x multiplied by x will give us what? Will give us a 3x squared. Good. Now, the factors of 4. You remember we said earlier on, factors of 4 is what? It's a 1 times 4. It's a 1 times 4, or 2 multiplied by 2, right? And now let's go to this one now. Between 1 times 4 and 2 times 2, which one do we take? Boys and girls, it's very important. Don't just take those factors and then put them there. Just make sure that at the end of the day, you get the middle term, because the middle term will be the one that will determine if your factors are correct or wrong. Right now, if you take 1 as well as 4, right, if you take 1 as well as 4, of course, you can multiply 3 with 1, and then what's going to happen there? You will have 3, nay. And then 3 plus 4 is what? It's 7, nay. Then it means this one is not going to work. Even if you take 3 times 4, then it will give you 12, right? And now 12 now, because now we have a plus sign here. It means we are adding, not subtracting there. Then it means you must add whatever that you're going to get there. Right. Now, this one is out. 2 times 2 is out. Now, let us look at 2 multiplied by 2. Right. Let us look at 2 multiplied by 2. If I write 2 here and then 2 here as well, what's going to happen? 3x multiplied by 2, it's a 6x. Is that correct? Yes, 6x, and then 2 times x is what? Is 2x. Now, when I take 6x plus 2x, what is the answer? The answer there, of course, will be 8. Now, can you see the smile on me? It means now I'm happy that these factors here are 100% correct because they are doing what? They are giving me the middle term, which is the most important part on these equations. Of course, now, what will be the sign now? Because it's a positive here, now we must have minus as well as a negative there. Good. And therefore, now we can now say, okay, we have 3x minus 2 is equals to 0. Therefore, x is equals to what? We take 2 on the other side. It becomes positive, and then we divide by what? We divide both sides by 3. That is why we have x is equals to 2 divided by what? 2 divided by 3. Right. Of course, the other one here is what? X is equals to 2. Right. Are you happy with the x value at the turning points? Yes. How do you determine the x value at the turning points? Of course, you take f, and then from f you find the derivative, right? And now that derivative, remember, is also the gradient. Of course, you need to let the derivative to be 0 because at the turning points, gradient is what? Gradient is 0. Then you equate it to 0, you solve for x. That is why we have x is equals to 2 over 3 or x is equals to 2. Right. I think you are happy now with this part here. Please make sure that you don't forget how to determine the turning points of the cubic functions. Good. Now, and then from here, what do we do now? We must find the corresponding y value. If x is 2, what is the corresponding y value? If x is 2/3, what is the corresponding y value? Right. Let me start with 2 first. F at 2, you said we take 2, we substitute it where? In the original. Please don't substitute it at the derivative. Do not substitute the x values at the derivative. Why? Because you are going to get 0, right? You are going to get 0. Do not substitute these values at the derivative. Okay, let me show you something here. It's not acceptable, this thing that is going to happen here. Look, if we take 3 multiplied by 2, all squared minus 8 times 2, and then plus 4. That will be what? That is 4. 4 times 3, I think, is 12. And then 8 times 2 is a minus 16 there. And then plus 4. 4 plus 12 is 16. 16 minus 16 is 0. You see now, please do not substitute your x values at a gradient, at a derivative. It's very, very important, right? Good. Now, where do you supposed to substitute this one here? At the original functions there, f at x, right? The one of the x to the power of 3. Right now, let us substitute that one here. Now, it means you are going to have what? We are going to have 2 to the exponent of 3 minus 4 times 2 squared and then plus 4 multiplied by 2. Right. This one here is going to be 8 and this one here is 4. 4 times 4, that will be 16 and then plus what? Plus 8. Good. And then 8 plus 8 is 16 and then 16 minus 16 is 0. Now, one will say, yes, that look at this one, you're also getting 0. You said you're not. Yes, here you are going to get 0. Because when you go back to your x and the y intercept, remember, one of the x values there, one of the x intercept is what? It's x is equals to 2. It means 2. It's the x value at the turning points, and it's also what? It is also the x-intercept of the functions. That is why we are having 0 there. I think you understood this one, right? Okay, good. Now let us look at the second one there. F at what? F at 2 divided by 3 there is equals to what? Is equals to, we are going to have what? 2 divided by 3 to the exponent of 3 minus 4 multiplied by 2 divided by 3 there squared, and then plus 4 multiplied by 2 divided by 3. Right. Of course, we can work this one out. That will be what? That will be, of course, 8 divided by 27 minus, this is going to be 4, right? And then 4 times 4 minus 16 divided by 9. And of course, this is going to be plus what? This is going to be plus 8 divided by what? Divided by 3. Right. We can quickly also work it out on the calculator to see what is it that we're going to get there. And now we have 2. We have 2. Let me put everything in. We have 2 divided by 3 all to the exponent of 3. And now minus 4 multiplied by 2 divided by 3 all squared. And now plus 4 multiplied by 2 divided by 3, right? And then this one we just multiply because it's the exponent of 1. Of course, at the end of the day, we are going to get what? We are going to get a 32 divided by a 27. Right. Now, the question now will be, what are the coordinates of the turning points? What are the coordinates of the turning points? Of course, the first one that we have here, x is what? X is 2, y 0. Right? That is the turning point that we have. And the other one here on this side, x is what? X is 2 divided by 3 there. And of course, and then the y will be what? Y will be 32 divided by 27. Right. We can also write it in the decimal form because at the end of the day, you are going to use that one in decimal form. Decimal form, then you're going to have what? Decimal form, we're going to have this side here is going to be 1 comma what? 1 comma 1 9 or 1 comma 2, and then 2 divided by 3, then it's going to give us what? 0.6, right? It's going to give us 0.7, right? These are the coordinates of the turning points. Good. Now we have the x and the y intercept. We have the turning points. So remember, how did we find the turning points? Yes, it's very, very, very important. Good. Now, what do you think will be the next question from here?